here at the AES show. I'm with Michael Deming on the Charter Oak stand. We've looked at Charter Oak microphones many times before. There's nothing new here today, apart from the whole technology has been redeveloped and moved over to manufacture in the USA rather than China.
Yeah. Well, actually, the microphones were never assembled or quality tested in China,
right.
But we imported a lot of components.
Okay.
We used to import brass castings and machine them in the U.S. And of course, we imported all of the accessories like the carrying case, the shock mount, etc. So, whereas for 10 years we made the microphones and tested them at our shop in Enfield, we imported many elements of the metalwork and the accessories.
Sure.
We hand-populated boards for 10 years in Enfield. So what we've done now is, we've gone to a 100% made in the USA model where none of the parts are imported with the exception of capacitors that we get from Nichicon, which are high-end KA and KZ series. We use some Panasonic capacitors, Epcos, etc. So, those of course are being imported, but we've even moved to 100% American-made resistors, which is, I think, odd to see in electronic products these days. Yeah.
So, what was the impetus for doing this? Because it must have a cost impact.
Well, actually, with the careful bidding process, it only resulted in about a $200 increase, $200 US increase in the retail price. So, in the professional audio business, $200 is not that significant.
Okay.
The retail price of the SA538 and 538B is still under $2,000, which is spectacular because the audio performance is, above 35. It's in that 3,500 to 5,000 and above range, as we all know.
Yeah.
And what we did was really on a level of refinement. We went to not change the schematic so as to change the overall sound of the 538 and 538B.
Yeah.
But we set out to refine the electronics and refine the metalwork in such a way that the microphone would perform better acoustically, perform better electronically, and basically just be a better version of the same microphone we've sold over 5,000 of in 10 years.
Wow, that's impressive.
So yeah, and we've been successful at doing it. We've spent all year doing it, and changing your manufacturing process obviously comes with the problems that you encounter in doing such a thing. So we've had delays in shipping and that sort of stuff, and we continue to work our way through technical issues, which are they're able to be conquered. It just takes
it's a process you have to go through.
That's right. It's brain power and manpower, and you put the two together and you've solved the problem.
Okay.
But at least what we can show you here today, is a production version of the new This is a 538B that we have here, and as I was explaining before, where we used to import brass castings from Asia and machine those in the U.S. to make them perfectly round and then send them to nickel plating. Now, these parts are made in the U.S. from raw U.S. goods, from 303 stainless, and this is machined to 3 decimal point tolerance.
Yep.
Okay, so it's more acoustically sound. All of the raw goods are American raw goods, the 6061 aluminum, the 303 stainless, all of that. This is kind of cool too because it eliminates nickel plating from the process, which is an incredibly toxic process. Yeah. And going to the nickel plating plant was always an experience for me. I was always surprised that anyone in there was living past a couple weeks of working in there. So it's much cleaner.
Okay.
And it's much more consistent.
Yes.
The capsule stand system is machined to 4 decimal points. So, we're talking 10,000ths of an inch tolerance. So, the ability to repeat these things and make matched pairs and do all of this stuff.
All the tolerances get better.
With the tighter tolerances, everything is a lot easier and a lot better.
Sure.
And what we discovered was that, the acoustical sound, the unit became more acoustically sound, whereas we might in the past find a resonance as we're QCing a model and mitigate that resonance with some damping material or some kind of thing like that. We find no resonance in any of these.
Okay.
Because everything's fitting together very tightly.
Yeah.
And the materials are better. The raw materials are better.
Good.
It's very, very simple. And then
so what about the electronic side of things then?
On the electronic side, what we've done is, we haven't changed the schematic at all. And, to show that, I've got both of the head amplifier cards here, the before and the after. Mm-hmm. And this is the before, okay? And as you can see, we've relaid out the board to accommodate some other parts.
Right.
We've gone to polypropylene caps in key areas.
Mm-hmm.
We no longer use the thick film resistors. I would say 90% of microphones, vacuum tube microphones, FET, whatever, wherever there's very high impedance here, you have very high value resistors.
Of course, yeah.
And typically values of 250 megs, 50 megs. So here we have a 1 gig resistor. Mm. These would be what we call thick film because you can get that high value in a small package.
Yes.
A metal film resistor, which would be what we would really want,
from a noise point of view,
would be the size of this road case with a value of 1 gig.
Yeah.
Okay, so when we did this project, we went to use all 1% American-made resistors. So we went to a company called Precision Resistive Products, mm-hmm. and we went to all 1% tolerances on the resistors. And you can see these red resistors here. These are all American-made 1% resistors. Mm-hmm. And in doing that, I got to talking to the engineers there about the problem with noise coming from those high-value thick film resistors. And he said, well, we are experimenting with a new technology called metal glaze. Uh-huh. These have been designed for great stability in medical power supplies.
Right.
They had no data on these as it relates to audio because they had not been tried in audio circuit. So we got samples, and you can see here, these are normal package sizes, and you have 1 gig, 50 meg, and 250 meg right there. And the result, as these were designed for great stability and temperature, we didn't know how they would perform noise-wise. We put them into the circuit, and the result was a 6 to 8 dB reduction in noise between these and these.
Well, that's worth having.
Yes, of course. I mean, when we're talking A-weighted noise measurements, this is down below where we can really hear in a normal room. But the result of it was that what was already a great sounding microphone becomes even better because now you put on the headphones and you get that feeling of like just a black hole. I mean, it is just dead air. It's dead silence. I think it is an improvement to the overall technical performance and the sound. And then when you couple that with, the change to all of these very high quality components, in every area on this circuit board, we're using the very best thing you can find on the planet.
Sure.
Even to the effect that we have new old stock polystyrenes, Italian-made polystyrenes from the 70s, which we got in a surplus. These sound incredible, and you can see the construction of this capacitor. I mean, it's just, not what we typically find today.
Absolutely.
So it's really, everything about this has been refined to the point where, when you put this together with the improvement in the metalwork and everything else, it adds up to something.
Good. So talking of everything else, a lot of microphones are using imported Chinese stock parts, shock mounts, power supply, stuff like that. You've taken a different approach again.
That's right. That was the other reason that we wanted to do that. There were two reasons, basically. One is that we always suffered from slow fulfillment because we have a small crew.
Right.
So my idea of going to a CM finally was to solve that so that we could, finally deliver in quantity and quickly.
Right.
The second thing was that I wanted to extricate ourselves from the group of brands that we'd been lumped in with, mainly because we used a Chinese carrying case and Chinese shock mount and Chinese power supply box. Those things, whether we assembled these microphones in Enfield and tested them there, those things made the product looked imported from Asia.
It creates an impression.
Whether or not it created an impression, whether or not you can't explain to end users that you're doing X, Y, and Z in America, and the process sheet is too complicated. Mm-hmm. You look at it and there's arrows going everywhere. You have all these vendors and all of these people doing different things, and it's too complicated.
Yeah.
So the other idea was to finally extricate ourselves from that group that we'd been lumped in with for the last 10 years. And, so I even eliminated the Chinese carrying case. We invested in tooling. We ordered cases made in New Jersey, which are made from a blow mold process that are water resistant, kind of like a gun case.
Yeah.
They're nice. They're light and they're durable, and they have a nice red anodized aluminum plaque with the brand on it.
Okay.
We're now shipping, of course, with the Rycoat mounts, which are very high quality, really the standard in the industry.
Yeah.
We always used Gotham cable for the 7-pin cable, so that was not an area that needed to be upgraded. You know, this Gotham GAC7 was always
sure. But it's a new power supply.
Oh yeah, the power supply itself has been completely re-engineered. You know, the metalwork is all American. The internal components are of the same quality as this. You find the highest quality Nichicon, KA and KZ filter caps.
Yeah.
You find a power transformer made by Haybor in Michigan, which is a manufacturer for many hi-fi brands, hi-fi stereos and so forth. So that transformer is over-engineered. It's well beyond the specs that are needed for this. And all the hardware is either Neutrik or Amphenol. It's all, of the highest quality.
Okay.
So this is a whole rework here,
Right.
Also, something that I've always wanted as an engineer was constantly variable patterns control.
Yes.
Okay, so instead of having
so it switched before?
Yeah, it was switched before. You had cardioid, omni, and figure 8, and 6 intermediary stages.
Yeah.
Okay, now you have
whatever you
constantly variable control from omni to figure 8, and then another little added feature is where you can pull this pot and it cuts the audio completely, but it's still keeping the heaters of the tube warm. So say you've set this somewhere you want to return to, you can go back and push it back in and you're right back at the same spot.
Okay.
So that's a convenient little thing for people.
So what we're looking at then is an all-American upgraded quality.
It's 100% American, with the exception of parts that I can't get in America, which don't perform. When you're talking about electrolytic caps, Nichicon is, they are delivering to us the best thing. And I've liked the sound of all the Panasonic parts over the years, and in those areas we haven't fixed what wasn't broken.
Quite right.
We've kept using what we were using.
Good.
But in the area of the resistors, where there's a lot of room for error and tolerance and manufacturing quality, we've gone to PRP. Big improvements, PRP 1%, and then of course the elimination of those thick film high value resistors, switching to these metal glaze.
Brilliant.
Big improvement.
Brilliant. I wish you good luck with it then.
Well, thank you very much. I appreciate it a lot, and I appreciate you guys coming by.
Cheers.
Okay, great.